So before we dig into module 2, just recapping, A, B, C, D, E. And there's an S, but we won't get into the S. The S is really good sourcing. So again, the A is the application, B is the brightness, and that includes the CRI and any color requirements that are needed in the job, not just the CCT and the lumens or the lux level that's required in the job application, but also the CRI, which is the color rendering index, how accurately that light shows the color. You have C, the control and circuitry, which I'm going to really touch on a little bit. You have D, the design detail, which I'm going to touch on a little bit. And you have E, engineering. Now, again, the full set is in the full course. And if you find that this framework is something that's really appealing to you, I really recommend you going into the full course and understanding much more that we've built in that course. So let's get into it. So application is the longevity gatekeeper. Understanding the application is so critical. So 3 application mistakes that shorten LED lifespan. Application is where most LED linear installations quietly succeed or fail. Not because the product is wrong, but because the real world conditions didn't match the assumptions made during the selection. So again, I like to use the spa scenario. Or I'll just put an LED strip and I'll waterproof it. And then that waterproofing isn't enough. I'll put an LED strip and I'll put aluminum channels and that should protect the steam, but then the vapor goes in. So even though it's indoor damp or indoor wet, and then you may need a specialized light to handle those harsh parameters in the indoor. So there's a mismatch, and you have to understand the nuances to say indoor and conditions, exposure, time, things like that. So when the application is misunderstood, the system may look fine at hand over, because this is where it all slips through. But when they operate under stress, it begins to fail exponentially sometimes. These mistakes are common because they rarely are documented or rarely taught and often invisible during installation. So the goal of this lesson is not to add complexity, but to help you spot the 3 application gaps that most directly affect longevity. 1. Assuming the environment is normal. Heat, airflow, and enclosed conditions are often treated as neutral when they're not. Recessed or enclosed locations, limited ventilation, materials that trap heat. So a good example of a material that may trap heat is installing a raw LED strip that's, let's say, for example, high powered onto plastic, like a laminated material. If you want your LED brightness to be maintained for a long time, you need to add some sort of thermal management to it. So LED components degrade faster when thermal assumptions are wrong, even if the specs are technically met. Another area where applications fail is when people design for appearance, not use. So the lighting effect is often designed for how the space should be used, not how it is used. So longer daily run times, as I mentioned, higher brightness than necessary, constant operation instead of intermittent use. And why these matters? Because usage patterns directly affect cumulative stress and lifespan. And the third mistake is treating all linear lighting applications as equals. So I commonly see this where the designer goes on Amazon, they don't know, and they say, okay, a 10 watt per meter LED for everything, or a 4 point whatever, 4.5 watt per foot LED for everything. They don't understand lumens, they don't understand what the application is. So let's think of a toe kick light that has this much space, and then on a cabinet light, and everything's getting specified the same. And then they just dump a bunch of dimmers onto it and think it's all going to dim and work fine. So they treat it as one. So you have to know the application. So it's feature lighting versus task lighting, accent lighting versus general illumination, decorative lighting versus functional lighting. And different applications tolerate stress differently, even with the same product. So I may have a very high output LED that's meant to use intermittently, and somebody may have used that LED in a 24-hour application. That product could undergo different stress, and then they may be environmental factors, like it's a really hot space or something like this, being used full time as opposed to being intermittently. I don't know if that's a good example. Or let's say an indoor LED, and it's in cove ceilings throughout the house, and then there's a cove ceiling in a bathroom, and even though it's not getting wet directly, it is getting some steam, and then over time corrosion starts to happen at the terminals. Another example might be I'm using a waterproof LED because I'm so worried, and then this waterproof LED is being used 24 hours, so the heat begins to trap in the silicone, and then the LEDs start to blank off, dots, you start to get dotting on the strip, and that's one I used to commonly see a lot, and I made those mistakes in the past a long time ago. But one of the biggest strains of those waterproof LEDs is that the heat has nowhere to go. So that's a great example. So these are the things to be mindful of in this application section.